This video is on Unit 6, Chapter 12, Exponential and Log Functions, Lesson number 6, which is just a review. So this is a recap of all the different types of equations that we studied in Chapter 12. The first set that we're going to look at are logarithmic equations. And remember that with logarithmic equations, you might have log equals a log, where you drop the logs and solve. The second one is log equals a number. When you have log equals a number, you need to rewrite it in exponential. And just as a reminder, if it says log base b of a equals x in exponential, that's b to the x equals a. Looking at question number 1, I've got log base 7 of 9x minus 4 is equal to log base 7 of x plus 20. So to solve this, log on both sides, we're going to drop the logs, and we get 9x minus 4 is equal to x plus 20. Subtract the x, and we get 8x minus 4 is equal to 20. Add the 4, and we get 8x equals 24. Divide by the 8, and you get x equals 3. Another thing that I would like to remind you of is that anytime you're using logs or there's a log involved in the problem, you have to make sure you check your solutions. To do that, plug the 3 back into the parentheses and make sure those parentheses do not turn into a 0 or a negative. So on the left side, 9 times 3 is 27, minus 4 is 23. I'm good. 3 plus 20 on the other side is also positive, so x equals 3 will work. On number 2, log base 5 of m squared minus 12 is equal to log base 5 of m. For this one, again, you have logs on both sides. So you're just going to drop the logs, and you get m squared minus 12 is equal to m. Now, for practice sake, I'm just going to give you the answers here. I would encourage you to practice this on your own so that you're ready for the test. You should get, when you solve this, you should get m equals 4 and m equals negative 3. The negative 3 is not going to work. So the final answer for number 2 is m equals 4. Moving on to number 3, it says log base 3 of 4 plus log base 3 of a plus 5 is equal to log base 3 of 56. So again, we have logs on both sides. So the goal here is going to be to drop the logs. But before we can drop the log, we have to consolidate the left side. So we have to condense it into 1. Because there's a plus in the middle, log base 3 of 4 plus log base 3 of a plus 5 is going to read log base 3 of 4 times a plus 5 equals log base 3 of 56. Now that we've got the left side condensed, we can drop the logs, and we got 4 times a plus 5 equals 56. Again, I'm going to allow you to solve that. Pause the video if you need to, finish solving it. See if you get the final answer. And the answer on this one is a equals 9. Again, you need to make sure you're plugging these in, checking them. A equals 9 will work. On number 4, log of 2y minus 10 is equal to 7 times log of 2 minus log of 8. So the right side is our issue at this point. We need to condense that. The 7 in front of the log of 2 is going to change to log of 2 to the 7th, and then I've got this minus log of 8. Well, 2 to the 7th power is 128. So this is going to be the log of 128 minus log of 8. And then because there's a minus, we need to divide. We're going to divide 128 by 8. So 128 divided by 8 gives me 16. So now this says log of 2y minus 10 equals log of 16. So we've condensed the right side. We've got log on the left, logs on both sides. Drop the logs, and you've got 2y minus 10 is equal to 16. Solve, and you should get y equals 13. And it does work. When you check it, it does work. Continuing on, number 5, log base 4 of 5m plus 9 is equal to 3. So this is one of the ones where there's not a log on both sides. There's only a log on the left side. So the strategy here is to change it to exponential. So rewriting this in exponential form, it's going to read 4 to the third power is equal to 5m plus 9. So go ahead and do 4 to the third power. 4 to the third power is 64. You'll finish solving that. In your notes, you should have all of the solutions written out here. You get down to m equals 11. Check your answer, and it does work. Number 6 is very similar. Log base 36 of 20 minus 4p is equal to 1/2. There is only a log on one side, so we're going to change it to exponential. 36 to the 1/2 power is equal to 20 minus 4p. So 36 to the 1/2 power is the same thing as the square root. So the square root of 36 is 6 equals 20 minus 4p. Again, you're going to solve that, finish that in your notes. You should come down to p equals 7/2. And again, when you plug that in and check it, it does work. Number 7, log base 6 of 7k minus 1 is equal to 3. Again, log on one side, rewrite it in exponential form. So 6 to the third power is equal to 7k minus 1. And you'll work that out. Again, pause the video, finish it out, check your answer. You should get k equals 31. And when you check it into the original equation, it does work. Number 8. Log of n plus 8 plus log of 4 equals 2. So for this one, as I look at it, I'm thinking, okay, I have a log on one side, but not the other. What I need to do on the left side is condense. So because there's a plus, I'm going to multiply the n plus 8 and the 4. So think about what 4 times n plus 8 looks like. It's going to be log of 4n plus 32 equals 2. Now, what is the understood base on this log? The understood base on a log that doesn't say what its base is 10. So rewrite that in exponential form, and it'll say 10 squared is equal to 4n plus 32. Again, finish that out on your own. You should get n equals 17. And it does work. Moving on to the next set of equations. These are our exponential equations. So there's two different things when you have exponential. With exponential equations, you either have same base or different bases. If you have same base, the same base on the left and on the right, then you're going to drop the base and solve. If we have different bases, then we're going to rewrite in log form. And again, you'll use that same the same method that I wrote over here. Log base b of a equals x becomes b to the x equals a. So example number 9, 25 to the v minus 2 is equal to 625. So I can tell you 25 squared is 625. So our base on this one can be a 25. Yes, you could have made it a 5, but 25 is going to work because 625 is 25 squared. So I've got 25 to the v minus 2 is equal to 25 squared. Now I have bases that are the same on both sides. Drop your bases and solve. B minus 2 equals 2. Solve it, and you get V equals 4. Because you're going to add your 2 to both sides. If you do check it, which is not always necessary here, because these are exponential and it doesn't say log, if you check it, it will work. On number 10, I got 1 over 16 is equal to 8 to the 4x minus 2. Again, we do not have the same bases here. However, I know that 16 is the same thing as 2 to the 4th power, and 8 is the same thing as 2 to the 3rd. Now, the 1 over 16 means that I need to make that a negative 4, because that's a fraction. We end up having to flip it. So 2 to the negative 4th is equal to 2 to the 3rd, and then we're going to have to multiply that times the 4x minus 2. So now drop your bases because we've made them the same, and our equation says negative 4 equals 3 times 4x minus 2. Again, you can solve that right here in your notes. Pause the video, solve it. You should get x equals 1/6. Number 11, 8 to the k is equal to 78. Now, I know there's no way for me to make these the same bases. So because they are different bases, I'm going to go ahead and change this to a log. Log base 8 of 78 equals k. So log base 8 of 78 gives me 2.095 for k. Again, you would need to make sure you take that and you check it. This is another one of those where it is absolutely necessary for you to check them always, because in the equation we are solving, we've got the word log in here. So you have to check. It does work to save time in my video. The next one, 9 to the n minus 6 is equal to 78. Again, there's no way to make these the same base. We're going to rewrite it in log form. So log base 9 of 78 equals m minus 6. Log base 9 of 78 gives me 1.98. We're going to make that a 3. The 8 makes a 2 a 3. 1.983 equals m minus 6. You need to add your 6 to both sides to finish this one out. And we get 7.983 equals m. Again, you must check, and it does work. Number 13. Before I can change this to log, you've got to get the exponential part by itself. So I'm going to minus the 7. 67 minus 7 is 60. And now I can rewrite it in log form. So log base 15 of 60 equals 3a. Log base 15 of 60 gives me 1.512. And then you have to divide both sides by 3. So divide by 3. 0.504 for A. And again, that works. Number 14. The first step is to minus the 9. So we get 14 to the 3 minus 8x equals 77 minus 9 is 68. And then rewrite in log form. Log base 14 of 68 equals 3 minus 8x. I'm going to let y'all solve this. At this point, you should be able to solve this on your own. Finish number 14 on your own, and I can tell you that your final answer will be x equals 0.175. Number 15, 8 times 3 to the n minus 1 minus 21 equals 51. The first step on this, of course, is to get this exponential part by itself. So we must add 21 first. 51 plus 21 is 72. Divide by the 8. 72 divided by 8 is 9. Rewrite in log form, solve, and I can tell you that the final answer is n equals 3. I would encourage you to go ahead and work number 16 on your own. Work it, finish it, complete it. The final answer here should be 0.425. So those are the notes, the review on your exponential and your logarithmic equations for chapter 12.